All right, day 3 of transitions. Today we're going to look at greatest common factor and least common multiple. I'm going to show you a couple ways of doing this. I'm sure it will look familiar to you once we get into it. But let's look at the definitions of these first. So GCF is what we call the greatest common factor of two positive numbers, and that is the biggest or largest number, the largest positive integer that will go into a number, into two numbers. All right, so let's say that I want to look at 12 and 18. I'm going to show you the first way of doing this. Notice this word right here. If you remember yesterday, we spent quite a bit of time talking about factors, the numbers that will go into our numbers. All right? So here I'm going to list every number that I can find that will go into 12. 1, 2, 3, 4, 6, and 12. 1 times 12, 2 times 6, 3 times 4. Those are every number that will go into the number 12. The next thing I'm going to do is I'm going to list all of the positive numbers that go into the number 18. 1, 2, 3. Think about 4, 5, 6, 7, 8, 9, and 18. And guys, if you'll look, I can pair these up. 1 times 18, 2 times 9, 3 times 6. Now what I'm going to do is I need to find everything they have in common. 1, 2, 3, 6. Those are the 4 numbers that they have in common. Look at the title, greatest common factor. I am looking for the biggest number that they have in common. So the GCF of 12 and 18 would be 6. That is the biggest number that they have in common that will go into both numbers. I'm going to come back to greatest common factor here in a few minutes, and I'm going to show you another way that you can find the greatest common factor. But this right here is probably the easiest way to make sure that you understand greatest common factor. All right, let's think about greatest common factor of a couple of other numbers. Let's do 15 and 25. And I know these are simple numbers, but that's okay. I need to list everything that goes into 15. So 1, 3, 5, 15. I need to list everything that goes into 25. 1, 5, 25. Notice I did not write 5 twice. Okay. I'm going to circle everything they have in common. Greatest, which means the biggest number they have in common. So the GCF would be 5. Every time you did greatest common factor, they turned around and did what they call least common multiple. or the LCM. So let's talk about how to find the least common multiple. Now, notice the wording has changed. Least, smallest. I'm still looking for something they have in common, but I'm no longer looking at factors. I'm looking at multiples. Guys, if I were to ask you to list the multiples of the number 2, you would simply go 2 times 1 is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Those are multiples of the number 2. Multiples are not the numbers that go into that number. Multiples are everything that the number 2 will go into. So you got to know the difference between factors and multiples. And this is probably one of the most challenging things to GCF and LCM, is that I see a lot of students get these two confused. Factors are what go into a number. Multiples are what that number will go into. The wording is a little similar, but the definitions are not the same. Okay, so let's look at the LCM, or the least common multiple, of a couple of numbers. Let's say that I want to do the LCM of 2 and 10. Once again, I'm looking at multiples. So I'm going to list. Guys, there is no possible way for you to list every multiple of the number 2. Here is my suggestion. I would suggest that you start off listing the first 5. If you do not have a number they have in common in the first 5, then add 5 more. I would not start listing the first 20 multiples or the first 15 multiples. I would start off by listing 5. So I have 2, 4, 6, 8, 10. List the first 5 multiples of 10. 10, 20, 30, 40, 50. This is where it's very similar to greatest common factor. Now I'm going to circle what they have in common. In this case, this is the only thing they have in common. So the LCM of 2 and 10 is 10. The smallest number that they have in common is 10. Let's say that I want to look at the number 3 and the number 6. So I'm going to start listing my multiples. 3, 6, 9, 12, 15, and I'm going to go ahead and list the first 6 there, because I want to show you something. I'm going to list my multiples of 6, 6, 12, 18, 24, 30, 36. Now you're going to circle what they have in common. I did 3 and 6 on purpose because I wanted you to see this. There are 3 things they have in common. That's the first 6 multiples of 3 and 6. There are 3 numbers they have in common. I've got to go back and look at my word here. I am looking for the least, the smallest number that they have in common. So I'm no longer looking at the biggest number. I'm looking at the smallest number they have in common. So the LCM of 3 and 6 is 6. Now, there is a different way for you to find GCF and LCM other than listing all of this. I'm going to show you that, and the reason I'm going to show you that is because you're going to see things written a little differently on different types of problems. You might have a prime factorization. You might have a number that's huge, and you're not going to want to sit and list all of the factors or all of the multiples. You may have a number that's you may have two numbers that requires you to write 20 to 25 multiples before you even find something they have in common. So I want to show you a second method on how to find GCF and LCM. Alright, so let's say that they want, or that they give us the numbers 36 and 40. And they tell us to find the greatest common factor and the least common multiple. Alright, so we can consider the prime factorization of our numbers. Sometimes you will be given this. Other times, if you want to find it, you can. It's your choice on what method. Guys, there is no one specific way that you have to do math. There are many, many different methods, and my job is to teach you all of the different ways that you can figure these things out. I am not set on one specific method. My goal is to just get you through it. So let's say that they give us the prime factorization of 36. And they say the prime factorization of 36 is 2 squared times 3 squared. And let's say they give us the prime factorization of 40, which is 2 cubed times 5. I can use this to find GCF and LCM. It's a little confusing, so you've got to stay with me. Okay? So if you're kind of, not really focused, pause the video, take a walk for a second, get you a drink, focus, because you've got to understand this. Alright, so let's say I want to deal with GCF first. I can find the GCF of two numbers by looking at the product of the largest power of each prime that is a factor of both of those numbers. So let me show you what I'm talking about. I'm going to look at this. I have 2 and I have 3 here. I have 2 and I have 5 here. The only thing they have in common is the base 2. Alright. So I'm going to pull out what they have in common here. I know they're not the same exponent, but they're the same base. Alright, so I'm going to look at this, and it says the largest power that they have in common. Well, this has 3 of those, and this has 2 of those. They both have to have 3 in order for me to use 2 cubed. They both have 2. They have 2 squared. So the GCF would be 2 squared, or 4. Look at this, guys. Same base. Now I've got to figure out how many I can pull out that they have in common. Guys, I can look at it like this. How many do they have in common? They have 2 squared. So my GCF is 2 squared, which is 4. Let's look at LCM. LCM is the product of the largest power of each prime. Notice I said each prime that is a factor of either of those numbers. All right, so let's go back to this for a second. I have 36 and I have 40. That's 2 squared times 3 squared. That is 2 cubed times 5. All right, so now I want to look. I want to see, okay, they both have 2's. This one has a 3. This one has a 5. I'm going to find the largest power between the 2 of them. This is where this one's a little bit different. Which one's bigger, 2 squared or 2 cubed? 2 cubed is bigger, so I'm going to pull that one out. But now I have to also multiply everything else. So 2 cubed times 3 squared times 5 actually gives me 360. So the LCM is 360. I can sit and list all of these multiples, but it's going to take me a while. Because 36, I would have to list the first 10 multiples of 36. I would have to list the first 9 multiples of 40 before I even have one number they have in common. So see what I'm saying when I say it can get a little long listing everything, but if you've got the prime factorization, you can figure those out. All right, don't fret. I know a lot of you are sitting here going, I don't get that, I don't understand it. We're going to do another example. We're going to look at this again. All right, so let's say that I have the numbers 20 and 27. Okay, I'm going to look at prime factorization. The prime factorization of 20 is 2 squared times 5. The prime factorization of 27 is 3 cubed. So, going back to greatest common factor, remember I told you to look to see what they have in common. Do you see anything they have in common? 20 has the base 2, the base 5. 27 has the base 3. There's nothing they have in common except for the number 1. I can multiply all of this by 1 and it doesn't change the value. I can multiply this by 1 and it doesn't change the value. So the GCF of 20 and 27 is 1. Let's look at LCM. LCM, I'm going to look. Once again, they do not have anything in common. So in order to find the LCM, I just have to multiply all of this together. So I have to multiply 2 squared times 5 times 3 cubed, which would give me 540. That is the LCM. All right. Let's do 2 more numbers. And then I'm going to throw a little bit of algebra in here and give you some letters, some variables. All right? I want to do two more numbers, and the reason I want to do these two more numbers is because they are a little bit bigger. So let's say I want to do 288 and 4,536. Okay, so do you really want to list all the factors, and do you really want to list all of the multiples of these numbers? Probably not. That's going to take a while. So, we're going to look at prime factorization. Alright, so the prime factorization of these two numbers is 288 is 2 to the 5th power times 3 squared. And 4,536 is 2 cubed times 3 to the 4th times 7. Alright, so let's use this to find our GCF and our LCM. GCF, I'm going to start off the bat and I'm going to figure out what they have in common. So they both have the base 2's and they both have the base 3's. Okay, so remember, I need to figure out what I can pull out. So I can look at it like this. Alright, so there's a 2, there's a 2, there's a 2. These 2's I can't do anything with because there's not a common one. So, in order to find the GCF, I'm going to have to multiply 2 cubed. Alright. Now I'm going to look at my 3's. So I've got 3 times 3, and 3 times 3 times 3 times 3. Look at what we have in common. I can't do anything with those 2 extra 3's. So 3 squared. So 2 cubed is 8, 3 squared is 9. So 8 times 9 is 72. So the GCF of 288 and 4,536 is 72. Let's find our LCM. Alright, I'm going to come back down here and I'm going to rewrite this so I can look at what they have. Make sure you guys can still see that. Alright, so now I'm going to go back and look at what they have in common. Now remember, at this point in time, I've got to pull the biggest one out. So I've got 2 to the 5th and 2 cubed. Which one's bigger? 2 to the 5th.